Welcome to What's Up Over Edmonton for the month of August 2023. My name is Jeff Robertson, and I'm a member of the Royal Astronomical Society of Canada, Edmonton Centre. I call this What's Up Over Edmonton because the skies over Edmonton are fundamentally different than what's presented in popular astronomy publications such as Sky and Telescope and Astronomy. And I use this picture as an example every month. This is Toronto on July the 5th at 11 o'clock. And we can see the constellation Scorpio fully above the horizon from Toronto. On that same day, at the same time, Scorpio, you only see the top of Scorpio. You never see the entire constellation. You never see its tail and its stinger. And it's not only what we see in Edmonton that is different than what's presented in a lot of publications. It's how we see it. And this is a picture I took in my own backyard back in February of the moon at the top left, Jupiter in the middle, and then Venus at the bottom right. And you can see they're arranged in a bit of a slant. And that same night, my wife's cousin, who is in Buenos Aires, Mexico, which is at 20 degrees north latitude, took a picture of the same scene with the moon, Jupiter and Venus, and you can see they're in a straight line. So it's not only what we see, it's how we see it. The ecliptic angle is quite a bit different here in Edmonton. Most of the information I use for What's Up comes out of the Observer's Handbook, which is put out every year by the Royal Astronomical Society of Canada. It's 352 pages of just about everything an amateur astronomer or observer would ever need to know. So what do we got in August? We've got longer nights and we've got lots of mosquitoes. And believe me, some nights they're really bad. So we've got the Perseid meteor shower, which is kind of the highlight of August, and it peaks on the morning of August the 13th. We've got Venus at inferior conjunction. We've been watching Venus for several months in the evening sky. It's in inferior conjunction this month, which means it passes between the Earth and the Sun and moves into the morning sky. We've got Saturn at opposition on August 27th, which means it will be rising at sunset at the end of the month. And we've got all the outer planets will be above the horizon before midnight by month's end. And we have the largest supermoon of 2023 on August the 30th. So I'll start the planetarium section. As always, I've pre-recorded it. And unlike the last few months, I've managed to keep it to a reasonable time. So here we go. Let's look at what's in the sky over Edmonton for the month of August 2023. And as always, we'll start with sunrise and sunset times. So today the sun rose at 5:51 a.m. It will set at 9:28 p.m. for 15 hours and 37 minutes of daylight. Night begins, that is, astronomical twilight ends at 12:55, and it ends at 2:33. So still not a lot of time where the sky is completely dark, but it is growing. On the 31st, the sun rises at 6:41 a.m. It sets at 8:26 p.m. for 13 hours and 45 minutes of daylight, and astronomical twilight ends at 10:40 p.m. So let's talk about the planets. Now, I will briefly mention Venus in the evening sky, and this is a representation of Venus at the beginning of the month, just before sunset. So you can see Venus is almost in a direct line with the sun. It's about 18 degrees away from the sun, but you're not going to be able to see it in the nighttime sky because it's setting around the same time the sun sets. Venus will be in conjunction with the sun on August the 13th. That is, it will pass between the Earth and the sun from our point of view, and then it will reemerge into the morning sky. Now, you can see Venus in the daytime if you know where to look with a telescope, and it will present itself as a very thin crescent, something like this. Here's Venus and the sun on the 13th, on the day of the inferior conjunction, and Venus is passing below the sun. I really hope they have at least one telescope at the RESC Observatory in Coronation Park pointed at Venus on this day and the day before and the day after, because it's a really cool view. I've seen Venus on a day of inferior conjunction, and what you see is just a really thin sliver of Venus illuminated by the sun, and you can almost imagine that sliver of light going all the way around the planet, kind of an ashen light type of effect. Anyway, it looks really cool. Half an hour after the sun goes down tonight, Mercury is only a couple degrees above the horizon. It sets at 10:13. If you follow it through the rest of the month, it just sets. By the 7th, it's pretty much gone out of the evening sky. It's a tough target. It'll be a fairly bright twilight still. And our old friend Mars is still hanging around. It'll be in the evening sky, although it'll be fairly low and tough to spot until it's at superior conjunction with the sun. That is, it swings behind the sun from our point of view. So it'll set tonight at 10:34, and by the end of the month it's setting at 9:06. So we've lost our friend Venus, which was delighting us for several months, and Mars is getting pretty tough to see, but don't despair, because the giant planets are starting to make an appearance in the evening sky, and we'll start with Saturn. And here we show it tomorrow night at 10:30, and it has just come up over the horizon. At the beginning of the month, Saturn is up at 10:25 p.m., and by the end of the month, it's rising at 8:24. Here is Saturn on August the 31st. Saturn reaches opposition. That is, it is in a line with the Earth and the Sun on August 27th, which means it rises at sunset. And of course, Saturn has its beautiful ring system, and in a medium-sized telescope, you can make out at least its large moon Titan, and a larger telescope will show you some of its smaller moons too. Joining Saturn in the late evening sky is Neptune. At the beginning of the month, it'll come over the horizon at 10:56, and by the end of the month, it will be rising at 8:57. And through a telescope, Neptune presents itself as a bluish disk at magnitude 7.82. It can be seen with a good pair of steadily held binoculars, but a telescope is really what you need to appreciate the disk. I've made the time a little bit later. It's 12:30 in the morning now on the 16th to show the last two planets, and the first one is Jupiter. Jupiter rises at 12:14 at the beginning of the month, and it's up at 10:20 by the end of the month. So by the time we roll into September, with the nights getting longer, both Jupiter and Saturn, which are naked eye planets, will be easily visible. And Jupiter, with its two large equatorial bands, which are seen even in a 60-millimeter telescope, is quite a sight. And you can also pick out its four big Galilean moons, Callisto, Ganymede, and Io. Europa, in this view, is behind the planet. Finally, we have Uranus, the first planet discovered in historical times. Uranus rises at 12:27 at the beginning of the month and 10:30 p.m. at the end of the month. Uranus shines at magnitude 5.73, so it is possible to see it with the naked eye if you're in a very dark location and know exactly where to look. Through a telescope, Uranus has this light blue, almost aquamarine color, and you can also see it in binoculars, but a telescope is needed to make out the disk. As I said earlier, Venus has left the evening sky and is going to move into the morning sky. And so here we have it set at an hour before sunrise on the 23rd of August, and here on the 24th we start to see Venus popping up an hour or so before sunrise, and by the 31st it's already starting to climb fairly rapidly. Now, I've been showing this drawing of Venus's path in the evening sky for the last few months. The path it takes in the morning sky is pretty much a mirror image of what it did in the evening sky. It's like it's flipped over. So it will start in east-northeast, rise fairly high, fairly quickly, and then descend into the southeast as the months wear on. So, If you're missing Venus in the evening sky, get up early and you can catch it in the morning sky starting near the end of the month and, of course, all through September and October. Let's look at where the moon will be in relationship to the planets. And for this first part, I've set it at 1 a.m. Tomorrow morning. So tomorrow morning, 2-day past full moon will be near Saturn. On the 4th and 5th, it'll be passing Neptune. On the 8th, it'll be quite close to Jupiter. And on the 9th, it's swinging past Uranus. The moon is new on the 16th, and on the 18th it will pass near Mars, but it's going to be really low on the horizon and in heavy twilight. So you might be able to see it with a pair of binoculars or a telescope, but, give it a go, I guess. I should mention on the evening of the 24th, the moon will be very close to the very bright star Antares in the constellation Scorpio. It actually occults Antares, but that happens during daylight hours. It won't be visible here in Edmonton, but it will be extremely close to the bright star Antares, which is this guy right here. And then back on the 30th, the moon is full again and passing Saturn. Now, it is the second full moon of the month, so that makes it a blue moon, and I'm going to talk about that a little bit later. But it is also the largest full moon of 2023. So you know what that means, folks. That's right, it's the supermoon. And I've expressed my thoughts on that term before. Suffice to say, I'm not a big fan of it, but if it does get people looking up at the sky, I guess I shouldn't complain. But I'm sure we'll hear a lot in the media, and we'll hear people saying, oh yes, I saw the supermoon, it looks so much bigger and so much brighter. And as I've shown this picture before of a couple pictures I took when the moon was super, and when it was at apogee, that is its furthest point from the Earth in its orbit, there isn't a lot of difference between the two. It wasn't really discerned by most people until the age of photography, when you can compare two pictures of the moon taken with the identical equipment. The highlight of August is, of course, the Perseid meteor shower, which peaks in the morning hours of August the 13th. Perseids are the result of the Earth passing through the trail left behind by comet Swift-Tuttle, which has a 133-year orbit. It was last here in 1992 and will be back again in 2126. So mark your calendars. Earth starts passing through the debris in July and will continue to do so almost to the end of this month. But its peak, when it passes through the center of this debris field, is on the morning of the 13th. And you can expect to see anywhere between 50 and 70 meteors per hour. And of course we call it the Perseids because the radiant point, the point where the meteors seem to be coming from, is in the constellation Perseus. And it's marked here by that white dot. Unlike previous years, the moon isn't going to be too much of a factor. It rises at 2:30 that morning, and it's a waning crescent, so it shouldn't interfere with your meteor watching. Of course, the best place to see the Perseids is away from city lights. Plan a spot, go early, set up, take a chair with you. Well, those gravity chairs work great. Take lots of bug spray. Take a blanket because it does get dewy and damp in the morning, or a sleeping bag. Stay warm, have a hot drink with you, and just enjoy the show. Meteor showers, you do not watch with telescopes or binoculars, you just use your naked eye, and the meteors go all over the sky. They originate from this radiant point in Perseus, but they go all over the sky. They go up, down, east, west, and go with a friend. Just enjoy the show. It'll be great. I'm hoping we have good weather this year too, and we're done with this smoke by the middle of August, but you never know. And the sun has been quite active for this year. There have been lots of solar flares, the odd coronal mass ejection. We've had reports of aurora visible even inside the city. The best place to keep on top of whether there is a chance of aurora is this website here, aurorawatch.ca. You can sign up for alerts that will go into your inbox and just be on the alert for aurora caused by high energy particles coming off the sun. And speaking of the sun, as those of you in Edmonton know, we've had a very smoky summer, and I'm afraid this may be the new normal, that we would have these smoky summers from all the forest fires. This is a picture my wife took with a point-and-shoot camera on July the 13th of the smoky sun, and you can see, even without a filter, you can see a sunspot group on the sun. Actually, you can see a couple sunspots. I posted this on our astrolist, and I called this Look Ma, No Filter. Now, normally when I close off this section of What's Up, I point out a few dark sky objects that you can look at. But I'm not going to do that today. I'm going to say, when you're out looking at the Perseids on the 13th in a dark location, have a look around at some of the other sites. Take in the beauty of a dark site. Below Perseus will be the Pleiades here, and in a dark site, the Pleiades are absolutely dazzling. Have a look at the Milky Way. I was with someone at the RAC Observatory a few weeks ago, and they said they've never seen the Milky Way because they've lived in the city all their lives, and maybe if they were out in the country, maybe it was cloudy, or maybe there was a full moon. You know, say at this time that I've sat here on the night of the Pleiades, 1:30 in the morning, have a look at the Milky Way. Have a look at the southern Milky Way, which is looking into the heart of our galaxy. And just appreciate that we are orbiting a star, one of almost a trillion within our own galaxy. Have a look at some of the constellations and try and see what the ancients saw when they named these things. Cetus, the sea monster. See if you can see this kind of a boat shape and then a tail. It's supposed to be a whale. But, yeah. Or Ursa Major. I mean, we can see the Big Dipper in the city, but see if you can pull out the legs of the Great Bear and its head, or the kite shape of Butes the herdsman, the keystone of Hercules, and try and make out his legs and arms. And I did say legs. The legs are on the top. Hercules is upside down in our sky. His arms are at the bottom. And Cygnus the swan, or the Northern Cross. See if you can see that. Or this is one that's pretty easy to spot from a darkest sky. It's the Great Square of Pegasus, and you can follow. He's an upside down horse, so see if you can follow his neck to his head and then his legs. That's all I'm saying. I guess appreciate the sky. Appreciate the sky. Look up and use Ursa Major to find the Little Dipper, or Ursa Minor, the Little Bear. Doesn't look much like a bear to me. I must say, it does look like a Little Dipper. But in the city, I can only see 3 stars in Ursa Minor or the Little Dipper. I can see these two guys at the end of the bowl, and then Polaris at the end of the handle. But I can never see the other 4 stars that make up the Little Dipper in the city. But out in the country, you can see that. So that's what I'm saying. Just appreciate the night sky. And I guess with that, I'm just going to close off and ask if there are any questions. Okay. Are there any questions, comments, Rotten Tomatoes? Nothing? Okay. I will go on to the moon.
Yeah, I had a question, Jeff, for you.
Oh.
Sorry. Later.
When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows a path every month of the year.
Okay, shoot.
Oh, sorry. No, I could have waited. That's okay. I just I was asked the other day. Someone was reading an article somewhere, and it was saying that the tilt of Jupiter's rings is going to be flat towards Earth, so that we won't really see the gap anymore. Have you
Are
heard
you
anything
talking about
about that?
Saturn rings or
What did I
Jupiter's?
say? Oh,
You
I'm
said
sorry. I meant
Jupiter.
Saturn. Geez, sorry.
Yeah, in a few
Saturn's.
years. In a few years, yeah, because as Saturn orbits the sun, it's tilted similarly to Earth. I can't remember. It's around 25 or 26 degrees. As it orbits the sun in its 29-year orbit, the orientation of the rings changes from our point of view. And yes, it will flatten out. So it'll be edge on, and we won't be able to see the rings for a few months. And then as it moves along in its orbit, they start to open up again.
And so when is that? Do you know? It sounded like
I think it's in about 3 years.
about 3 years. Okay.
Yeah.
Okay.
I talked about it on a WhatsApp last year, or maybe the year before. So maybe it's only 2 years now. I can look it up later.
Okay. All right.
Yeah.
Just
Okay.
curious. Thanks.
Okay. All right. The moon was full on August the 1st, and it was a super moon. Some people describe supermoons as any time a full moon is closer than 360,000 kilometers from the Earth. The average distance to the moon is 385,000 kilometers. So, but of course, like the planets, the moon's orbit is elliptical, so it does change. Okay, so the moon was full on August the 1st, and it was the sturgeon moon. It's also known as the berry ripening moon, the green corn moon. I guess the corn maze opened last week. So barley moon, the fruit moon, or the grain moon. Third quarter is on August the 8th. The moon is new on August the 16th. And first quarter is going to be on August the 24th. And then on August the 30th, we have another full moon, and that is now popularly known when there are two full moons in the same month. We call that a blue moon. Now, the moon won't actually turn blue unless we have a volcanic eruption that throws a whole bunch of sulfur into the atmosphere, and then that'll tint the light, reflecting off the moon to a slightly blue hue. But the term blue moon for second full moon in a month originated, well, the original story was in the Farmer's Almanac. If there was 4 full moons in a season, because normally it's just one full moon a month. If there were 4 full moons in the season, they would call the third full moon in the season the blue moon. Sky and Telescope magazine started calling anytime there was 2 full moons in a month a blue moon. And it's kind of stuck, and it's kind of affixed to the media, but it will not turn blue. But it is also a super moon, as I mentioned earlier. It's actually more super than the one on August the 1st. The August the 1st supermoon was 357,000 kilometers from Earth. The one on the 30th is 356,000 kilometers from Earth. So it's 1,000 kilometers more super than the one on August the 1st. Everybody got that? It's also known as the flying up moon. Now, for the feature on the moon, I try and pick something out of either the RASC's Explore the Moon with Binoculars or Explore the Moon with a Telescope certificate program. I picked one from the telescope program this month. And it is the straight wall, or Rupus recta. And you can see it pointed there, just past the terminator. There it is, circled. It doesn't show up in this picture, but this is a close-up view of it. And it is a 110-kilometer long linear fault in the southeastern part of Mare Nubian, or the Sea of Clouds. It lies east of the 17-kilometer wide Brit crater. That's the Brit crater right there. Now, it rises approximately 300 meters above the surrounding terrain and has a width of 2 to 3 kilometers. And it is a popular target for amateur astronomers. Now, at the south end of the feature is a group of mountains, kind of a strange shaped group of mountains, the shape of which has been compared to a sword handle with the straight wall representing the blade. So one day after first quarter moon, the rising sun makes it cast a dark shadow to the west across the Sea of Clouds, giving the impression it must be a massively high cliff. And as the moon reaches near last quarter or third quarter, the sunlight illuminates the straight wall from the other side, and it causes it to appear bright. And here you can see the shadows in the craters have flipped, and the straight wall is widely illuminated. Although it appears to be a vertical cliff, it's actually a pretty gentle grade, relatively shallow, about 10 degrees. So if you're coming off Rupus Recta or the straight wall, it would be more like this. Nice gentle walk, and not like this. So last month I picked the constellation Aquila as the brightest star within that constellation, formed one of the corners of the summer triangle. Continuing on that path, let's look at Lyra, which contains the brightest star that forms the point of the triangle. And this is the star field in which Lyra, the harp, lies. There's an astronomical drawing of it. You can see it in the center of the photo, as that squashed box with a bar over top of it. And this is the shape the ancients thought they saw. They saw it as a harp or lyre. Lyra is found high in our summer sky after dark, and it represents the lyre or harp, and it is home to the bright star Vega, which forms one of the corners of the summer triangle. And there's also a couple Messier objects, as well as some NGC deep sky objects within the constellation. It was first cataloged by the astronomy Ptolemy in the 2nd century. Constellation is associated with the myth of the Greek musician and poet Orpheus. And Orpheus was known for his ability to charm even stones with his music, for his attempts to save his wife Eurydice from the underworld, and for being the harpist and companion of Jason and the Argonauts on their quest for the Golden Fleece. Orpheus met his end at the hands of female followers of the god Dionysus, who ripped him to shreds for not honoring said god. When he died, his lyre was thrown into a river by his killers. Zeus sent an eagle to get the lyre and placed it in the sky. So let's look at 3 objects in Lyra that are favorite targets for stargazers. So Vega is the brightest star in the constellation Lyra, and it's actually pronounced Vega. But thanks to when I was born, oh, there it is there. But thanks to when I was born, the Chevy Vega with its melting engine is imprinted in my brain. So it's going to be Vega from here on in. Vega is only 25 light years from Earth and shining at magnitude 0.03 is the second brightest star in our summer sky after Arcturus, and it is the 5th brightest star as seen from Earth. Vega is 2.1 times the mass of our sun and is approximately 455 million years old, so it's not that old. It's type A star with a surface temperature of around 10,000 degrees Celsius compared to our own sun's 6,000 degree Celsius surface. Now, back in 1983, one of the early results from the Infrared Astronomy Telescope, or IRIS, was the discovery of a dust disk around Vega. And this was seen as possibly the early signs of a planetary system forming there. Now, this was before the first exoplanets were found. And I suspect that this discovery may have been while Carl Sagan used Vega as the source for the extraterrestrial signal in his 1985 novel Contact, which was later made into a movie. Now, today, while Polaris lies near the North Celestial Pole, due to precession, which is a 26,000-year cycle where the Earth wobbles on its axis like a top, Vega was the pole star in 12,000 BC and will be again around AD 13,700. So it's kind of near the pole, but not really, but it's the brightest star near the pole for those folks in the future. M57, or the Ring Nebula, is a planetary nebula, the remains of a sun-like star at the end of its life. Now, as a star, like our sun, dies, it puffs off the outer layers of its self, which forms the nebula, which is illuminated by the white dwarf at the center, which is the dying husk of the once sun-like star. The term planetary nebula is a misnomer, has nothing to do with planets. The term originated from the planet-like round shape of these nebula observed by astronomers through early telescopes, specifically the discoverer of Uranus, William Herschel, who described these nebula as resembling planets. Now, it is tilted toward Earth, so we see the ring face on, and it resembles a smoke ring or a donut. Donuts. M57 is about 2,000 light years away and has an apparent magnitude of 8.8, and it can be seen in a moderately sized telescope. In images, the Ring Nebula is shown as a colorful sight, but at the eyepiece, as our eyes don't pick up those nice colors, the observer will only see it as a gray ring. Last of the three objects I'll talk about in Lyra is Epsilon Lyra, which is a multiple star system approximately 162 light years away. Now, to the naked eye, Epsilon Lyra appears as a single star. In a small telescope, it splits into two stars. And in a medium size or larger telescope at high magnification, each of these two stars reveal themselves each as double stars, hence the nickname, the double-double. It's a favorite target at our observatory in Coronation Park during the autumn months. It shows up really well in our 7-inch refractor. So we'll go on to space history. And this is where we look at a past event that not only occurred in this month, but whose anniversary year is divisible by 5. So in 2023, it'll be events that happened with years ending in a 3 or an 8. Now, for this month's history section, I'm going back more than a few years, but I'm not entirely certain that this event happened in August because I couldn't find an exact date for it, but it would have happened during or around this month. It's the publication of this book, and my Latin is horrible, so De Revolutionibus Orbium Solestium, or On the Revolutions of Celestial Spheres, by Nicholas Copernicus in 1543. Now, although the 3rd century BC Greek astronomer Aristarchus of Samos proposed a heliocentric model of the solar system, placing the sun, not the Earth, at the center, other Greek philosophers like Plato and Aristotle believed the Earth was unmoving, with the solar system, indeed the whole universe, revolving around us. Now, this model worked for the stars and the moon, but it presented a problem with the planets. Planets moving against the background stars would at times slow down, stop, reverse themselves, stop again, and then resume their original directions. And now we know this now as retrograde motion, and I did give an explanation of that during What's Up last October. It was the astronomer Ptolemy, living in the 2nd century, who came up with the idea of epicycles, transparent celestial disks that the planets sat on, spinning as they orbited the Earth, to explain this motion. Now, if you've been to Disneyland, think of the teacup ride, because it's kind of the same idea. You're spinning around an axis while the axis itself is spinning in the teacup ride. Nicholas Copernicus, born in 1473, died in 1543, was a mathematician and astronomer who proposed that the sun was stationary in the center of the universe and the earth revolved around it. He formulated the theory as early as 1510, but at the time, Copernicus's heliocentric idea was very controversial, and it could get one killed, usually in a very sadistic manner. The church of the day took a very dim view of a sun-centered solar system because it would mess up a lot of their theology, like Joshua telling the sun to stand still in the sky. He wrote his work on the revolutions of celestial spheres in 1539 and entrusted it to one of his students, but asked it not be published until after his death. He died in May of 1543, and the book was published that same year. And some of the main points of Copernicus's theory were that there was no center of all the celestial cycle. Let's try that again. There is no one center of all the celestial circles or spheres. All the spheres surrounded the sun as if they were in the middle of them all. Whatever motion appears in the firmament arises not from any motion of the firmament, but from the earth's motion. What appears to us as motions of the sun arise not from its motion, but from the motion of the earth and our sphere. And the apparent retrograde and direct motion of the planets arises not from their motions, but from the earth's. Now, Copernicus did believe the sun was the center of the universe and all the orbits were circular. And it wasn't until 1609 when Johannes Kepler, with his 3 laws of planetary motion, showed us that the planets' orbits are ellipses, not circles. And as it had not yet been established in 1543, Copernicus could not have known that the center of the universe is in Toronto and not the sun. And with that, I will say Heavens Above is a great source of information for comets. You can print star maps for your area, for your exact time. You can track satellites. You can track the ISS. You can track all the Starlink satellites flying around up there. It's a great source, and they don't pay me to say that either. The next What's Up is Wednesday, August 30th. We have 5 Wednesdays this month, so we're going to do September on August the 30th, Supermoon Day. The next RASC regular meeting is Monday, September 11th. Take a break in July and August. We don't meet. And with that, I'll say thank you. And are there any questions or comments?
But good presentation, Jeff.
Oh, thank
Really
you.
good. Yeah, always
Yeah.
informative.
Yeah, hope you like the little side bits of humor, or I thought it was funny anyway. Sometimes my wife doesn't think I'm funny.
They never do.
No, they never do. Anything else? Well, okay. Well, thank you again for joining us tonight. I'm looking out my window. It's getting a little gray out there, so maybe we will get a storm. This is recorded. I will edit out some of the goofs, fix that date, and post it on our YouTube channel, which you can find on our website, edmontonresc.com, in a day or two. And with that, I will say good night and thank you.
Thanks, Jeff. Appreciate it.
Yep.
Talk to you soon.
Thanks, Jeff.
Thanks, Ed.
Have a good night.
Yeah, you too.